Development history. The F-22 Raptor was developed under the United States Air Force's Advanced Tactical Fighter (ATF) program during the final years of the Cold War. Its primary objective was to replace the F-15 Eagle and ensure absolute air superiority against emerging Soviet fighter designs such as the Su-27 and MiG-29. The F-22 first flew in 1997 and officially entered operational service in 2005. The program emphasized dominance in beyond visual range combat while retaining unmatched close-range maneuverability. Despite its technological success, production was limited to 187 operational aircraft due to high costs and shifting strategic priorities. Key specifications: Role: Air Superiority Fighter. Maximum speed: Mach 2.25. Supercruise speed: Mach 1.8, without afterburner. Combat radius: approximately 850 kilometers. Radar and /APG-77 active electronically scanned array (ASA). Engines: 2x Pratt & Whitney F119 PW100 with thrust vectoring. Key capabilities and technology. The F-22 was the world's first operational fighter to fully integrate stealth shaping, radar-absorbent materials, supercruise, advanced sensor fusion, and thrust vectoring engines into a single airframe. Its stealth profile significantly reduces radar detection, allowing it to engage enemy aircraft before being detected. The aircraft's avionics system fuses data from radar, electronic warfare sensors, and off-board sources into a single, highly intuitive display for the pilot. This enables superior situational awareness and faster decision-making in complex air combat environments. Combat role and strategic value. Designed primarily for air dominance, the F-22 excels at intercepting and neutralizing enemy fighters, protecting high-value assets, and establishing control of contested airspace. Its ability to supercruise allows rapid response without compromising stealth or fuel efficiency. Assessment. The F-22 Raptor is widely regarded as the most capable air superiority fighter ever built. Although its production was limited, it remains unmatched in a combination of stealth, speed, sensor integration, and maneuverability, setting the benchmark for all modern fighter aircraft. Development history. The F-35 Lightning II was developed under the Joint Strike Fighter (JSF) program, one of the most ambitious and complex military aviation projects in history. The goal was to create a single multi-role fighter platform that could replace several aging aircraft types across the U.S. Air Force, Navy, Marine Corps, and allied nations. The F-35 first flew in 2006 and achieved initial operational capability in 2015. Three main variants were developed: the F-35A for conventional takeoff and landing, the F-35B with short takeoff and vertical landing capability, and the carrier-based F-35C. This modular approach allowed the aircraft to serve a wide range of missions across different services. Key specifications. Role: multi-role stealth fighter. Maximum speed: Mach 1.6. Combat radius: 100 km, variant dependent. Radar and /APG-81 ASA. Engine: 1x Pratt & Whitney F135. Key capabilities and technology. Unlike traditional fighters, the F-35 was designed around information dominance rather than raw speed or maneuverability. Its advanced sensor suite combines radar, electro-optical targeting, distributed aperture systems, and electronic warfare sensors into a single fused picture of the battlefield. The F-35 can detect, track, and share targeting data with other aircraft, ships, and ground forces in real time, acting as an airborne sensor and command node. Its stealth design allows it to penetrate heavily defended airspace and perform strike, reconnaissance, and air defense suppression missions. Combat role and strategic value. The F-35 is optimized for first day of war operations, where it can neutralize enemy air defenses, conduct precision strikes, and provide intelligence support to joint forces. Its networking capability significantly enhances the effectiveness of allied forces operating alongside it. Assessment. While not designed as a pure dogfighter, the F-35 is considered the most advanced multi-role combat aircraft currently in service, redefining modern air warfare through sensor fusion and network-centric operations. Development history. The Su-57, originally known as the PAK-FA, represents Russia's entry into fifth-generation fighter development. The program was launched to replace legacy platforms such as the Su-27 and MiG-29 and to counter Western stealth fighters. The aircraft first flew in 2010 and began limited operational service in the early 2020s. The Su-57 was designed with a different philosophy compared to Western stealth fighters, prioritizing maneuverability and kinetic performance alongside reduced observability. Key specifications: role, multi-role air superiority fighter. Maximum speed, Mach 2.0 plus. Combat radius, 500 km, estimated. Radar, N036 Bielka AESA, multiple arrays. Engines, twin engines with 3D thrust vectoring. Key capabilities and technology. The Su-57 emphasizes extreme agility, enabled by its advanced aerodynamic design and three-dimensional thrust vectoring engines. This allows the aircraft to perform complex post-stall maneuvers in close-range air combat. Its sensor suite includes multiple radar arrays and infrared search and track systems, giving the pilot strong situational awareness, particularly in environments where stealth is degraded. Combat role and strategic value. The Su-57 is intended to conduct air superiority missions, long-range interception, and precision strikes, often operating in coordination with other aircraft and ground-based systems. Assessment. The Su-57 is highly capable in maneuvering combat and high-speed engagements, though its operational numbers and full stealth maturity remain limited compared to Western counterparts. Development history. The J-20 Mighty Dragon is China's first indigenous fifth-generation fighter and a landmark achievement in its military aviation program. The aircraft first flew in 2011 and officially entered service with the People's Liberation Army Air Force in 2017. The J-20 was designed primarily to address regional strategic requirements, focusing on long-range operations and countering high-value airborne targets. Key specifications. Role, stealth air superiority and interceptor fighter. Maximum speed, approximately Mach 2.0. Combat radius, estimated over 1,000 kilometers. Radar, indigenous AESA radar. Internal weapons bays. Key capabilities and technology. The J-20 features a large airframe optimized for long-range interception and frontal stealth. Its internal weapon bays allow it to carry air-to-air missiles while maintaining a low radar cross-section. The aircraft is believed to integrate advanced data links and sensor fusion, enabling cooperative operations with other air and ground assets. Combat role and strategic value. The J-20 is designed to challenge enemy air superiority assets, airborne early warning aircraft, and tankers, playing a key role in anti-access and area denial strategies. Assessment. The J-20 represents a significant leap forward in China's aerospace capabilities and continues to evolve as newer variants and engines are introduced. Development history. The F-15EX Eagle II is the latest evolution of the legendary F-15 platform, originally introduced in the early 1970s. Rather than replacing the F-15, the EX variant was developed to extend its service life into the modern era, incorporating advanced avionics, digital architecture, and enhanced payload capacity. The F-15EX entered U.S. Air Force service in the early 2020s. Key specifications. Role, multi-role air superiority fighter. Maximum speed, Mach 2.5. Combat radius, 270 km. Radar, /APG-82 AESA. Engines, 2x Pratt & Whitney F100 or GE F110. Key capabilities and technology. The F-15EX is not stealthy, but it compensates with exceptional payload capacity, powerful radar systems, and long-range weapons integration. It can carry hypersonic weapons and advanced air-to-air missiles, making it a formidable missile truck. Assessment. The F-15EX remains one of the most powerful non-stealth fighters in service, combining proven airframe performance with modern digital warfare systems. Development history. The Eurofighter Typhoon was developed by a consortium of European nations including the United Kingdom, Germany, Italy, and Spain. Designed during the Cold War and introduced in the early 2000s, it was built to counter advanced Soviet-era fighters while maintaining multi-role flexibility. Key specifications. Role, multi-role fighter. Maximum speed, Mach 2.0. Combat radius, 390 km. Radar, Capture AESA, new variants. Key capabilities and technology. The Typhoon excels in high-speed interception, agility, and air-to-air combat, supported by advanced avionics and electronic warfare systems. Assessment. It remains one of the most capable fourth-generation plus fighters, widely used across Europe and Allied air forces. Development history. The Dassault Rafale was developed by France as an independent multi-role fighter capable of operating from land bases and aircraft carriers. It entered service in 2001 and has since been adopted by multiple international customers. Key specifications. Role, omnirole multi-role fighter. Maximum speed, Mach 1.8. Combat radius, 850 km. Radar, RBE-2 AESA. Key capabilities and technology. Rafale integrates advanced electronic warfare, sensor fusion, and multi-role flexibility, allowing it to perform air superiority, strike, and reconnaissance missions in a single sortie. Assessment. The Rafale is widely regarded as one of the most versatile combat aircraft in the world. Development history. The Su-35 Flankery is a deeply modernized evolution of the Su-27 airframe, conceived to extend the relevance of Russia's fourth-generation fighters into the 21st century. Development focused on bridging the capability gap between legacy fighters and fifth-gen.